Good day everyone. Today I'll be recording a Pure Math Unit 1 video, and specifically cubic polynomials. So first, from cubic polynomials, before we even get into that, we need to know these fundamental things, and these are things from quadratics. So we know that for quadratics, when we have, well, for example, we have a quadratic that says x squared minus 2x plus 1 equals 0. We know that the sum of the roots of this quadratic is equal to minus b of a, right? And in this case, it will be minus times b. The b value here will be the second term, or it's not always going to be the second term. It's this term which has the degree, the second to highest degree of the polynomial in this case. Well, in cases with cubic polynomials as well. So minus b over a will we'll say a is equal to 1. So we'll have a equals 1, b is equal to negative 2, and c is also equal to 1. So we'll have minus times minus 2 over, because it's minus b over a is 1. When there's nothing beside an x squared, we're going to assume that well, actually, we're not going to assume, the coefficient is 1. So it's minus 2 over 1. So the sum of the roots is equal to 2 over 1, which is equal to 2. Now, for the product of the roots, what you need to know is that the product of the roots of a quadratic is equal to c over a. And that's equal to 1 over 1, which is equal to 1. So I hope you understand that part before we even really start cubic polynomials. And now we will start. So in cubic polynomials, there's something slightly different. So I'll just write it over here. The sum of the roots, let's say we have alpha plus beta plus gamma, is equal to minus b over a, which is the same. However, next what we'll need to know is the sum of the product of two of the roots at a time. Now that sounds very difficult just listening to it, but I'm going to say it again. The sum of the product, so the sum of the product of two of the roots, so the product of two of the roots, the sum of that, two at a time. So meaning two roots at a time will be multiplied, and then they will be added to each root, because as you know, a cubic polynomial has three roots. So the sum of the product of all three roots will be alpha beta plus alpha gamma plus beta gamma, and that's equal to c over a. And we'll go to the c value and just pick that, right? And next, what we'll have here is, if we want to multiply the roots, we'll have alpha beta gamma, and that's equal to minus d over a. Okay, so I'm going to start off with a question. This is very fundamental kind of things. I'm going to start off with a question that seemed to have given my classmates a lot of problems during a test that we got for pure math recently. So we'll start with this. Given that alpha beta gamma are the roots of an equation, so we're given that alpha beta gamma are the roots of an equation x cubed plus 3x plus 2 equals 0. We need to form an equation whose roots are alpha beta, alpha gamma, and beta gamma. Now, I just completely skipped a whole step with normal cubic polynomials, because this normal cubic polynomials is just substitution, right? Like, I think it's very straightforward if you understand these three formulas, but we'll actually have to get to that anyways, right? So I just wanted to use a question that uses both, not both, but a more harder concept, and I believe that it's better to be challenged now when watching a YouTube video learning the topic than it is to be challenged while actually in the exam. So, well, that's actually what my peer math teacher says as well. But let's go. So first of all, the first thing we'll always have to do, I kind of like to think about it like math induction, where they're like rules. The first rule I always give myself, if we have x cubed plus 3x plus 2, I always try to look for these over here, these things. the minus b of a, the sum of the roots, the sum of the products of two of the roots of the at a time, and the product of the roots. But here's one thing that you notice, right? This has three values. This has three, not values, sorry. This has three different things in the equation, which would mean it's very similar to a quadratic. So what would be the difference between this and a quadratic? Well, if you look very carefully, we know that we have a polynomial of degree 3. If you don't understand degrees or of degree 3, I also made other videos on polynomials. It's right before this video, and I think it would be very, very beneficial for you to understand that before you come here. So what we'll notice is that there's no squared, because cubic polynomials are written in the form, let's write this over here, ax cubed plus bx squared plus cx plus d. So if it is that the middle part, which is this b value right here, is missing, it means that b has a value of 0. No, yes. So what I like to do, just to make sure that I'm doing everything properly, I have x cubed plus 0x squared plus 3x plus 2. It's very important for you to understand this little format of polynomials, especially cubic polynomials, because lots of times examiners will use these to trick students who aren't very vigilant. So whenever you're getting a cubic polynomials question, always check to see the different degrees. And for example, I could have a squared on the 3x and it would be missing a normal c value. And yeah, and the d will always be the value that remains constant, which is the 2 in this case. That's the d value. So first of all, we want to find the sum of the roots of this equation. So let's say the roots of this are alpha, beta, gamma, right? If we want to find the sum of the roots, that means that we want to find the sum of alpha, beta, gamma. Alpha plus beta plus gamma. And that's equal to which formula above? Now, the sum of the roots formula is equal to minus b over a. Now, in this case, right, before we even get to this, I'm going to write down all the values that we have so far. So we know that a is equal to 1 because this is the a value. We know that b is equal to 0 because the polynomial with the second highest degree would be the b value in a cubic polynomial, a polynomial with the degree 3. And then the third value, which would be the c value, would be equal to 3. And then our d value, as we stated earlier, would be equal to 2. So if we have minus b over a, right, we'll have minus 0, which is not possible, but minus 0 over 1 because a has a value of 1. And that's going to be equal to 0. 0 divided by a number is 0, but as long as 0 is not on the bottom of the fraction, right? Otherwise, it will be undefined. Okay, it's a very important thing to know. 0 divided by 1 is equal to 0, but 1 over 0 is undefined. Right? I won't write it all out. So if we want to find alpha plus beta, alpha plus beta plus gamma is equal to 0. Next, we want to find the sum of the product of two of the roots at a time, which would be alpha beta. So here's how you do it. You add these two, alpha beta plus, then you add these two as well. You just keep on skipping, so beta plus beta gamma, and then you add the end, the first and last terms, plus alpha gamma. And that's equal to which formula above is this equal to? This is equal to c over a. And from here, we can see that the value of c is 3. So we'll know that c over a is equal to 3 over the value for a is also 1. So it's 3 over 1, and that's equal to 3. So far, we know the sum of the roots is equal to 0. The sum of the product of two of the roots at a time is equal to 3. Right? So now, we just need to find the products of the roots, which would be alpha, beta, gamma. And that's equal to minus d over a. Now minus d, we know that d has a value of 2, right? So d has a value of 2, we'll have minus 2 over, and we know a of its value is 1. So that will give us minus 2 over 1 and equal to minus 2. So I'll just jot down right here the sum of the roots. C over A equals 3 and product minus 2, because we'll need this, right? So the question asked us to find an equation whose roots are alpha are alpha beta, alpha gamma, beta gamma, right? So because it asked us this, there's one thing that you need to know, very important. The format, I guess you could say the format of a cubic polynomial is this. We will have x cubed minus sum of the roots plus sum of the product of two of the roots at a time minus product. In other words, this is equal to x cubed minus b over a plus c over a minus d over a, and that would be equal to 0. So this is the format that we always need to remember when we have questions like this. If it is now that we want to find the equation whose roots are alpha beta, beta gamma, and alpha gamma, the first thing we'll need to do, right? The very first thing we'll need to do is find the sum of the roots. That would be equal to alpha beta plus alpha gamma plus beta gamma. But there's one thing we should notice here. They're asking us to find the sum of these roots. But if you notice, this is in the exact form of the sum of the product of two roots at a time. So, without having to even work this out, we know the sum of the product of two roots at a time is equal to c over a. So we'll use the values from the other equation, because the other equation has alpha, beta, gamma, and these would be the same roots, right? Yeah. So we know that this will equate to 3, because earlier, right here, we have our c over a value being 3. Hope you understand that part so far. It's going to be very weird when learning this at first. You probably might not understand it just from looking at it, but at the end of the video, you'll probably at least have a better understanding. And if you don't, click on another video and watch someone else's channel, whatever works. So now we have the first value, because if it is that a cubic polynomial is in the form x cubed minus the sum of minus the sum of the roots, so we have x cubed minus 3 so far, minus 3x squared. I forgot to add x squared here, and this would be x, right? So now we have this. So now we have question mark minus question mark, because we haven't worked these out yet, right? So if it is that we want to get the sum of the product of two roots at a time, which is the c over a value, what will we do? Hopefully you're writing this in a notebook while working it out. But let's say if we want to find sum of the product of two roots at a time, we add these two. Well, we multiply these two. So we'll have alpha beta times alpha gamma plus another two roots, alpha gamma times beta gamma, right? And then we'll have this plus what? The first and last, right? So that's alpha beta times beta gamma. Right, now we can simplify this. Alpha beta times alpha gamma is equal to what? It's equal to alpha squared times beta gamma. So we'll have alpha squared beta gamma plus alpha gamma times beta gamma, the same thing as saying alpha beta gamma squared, because we're just expanding these brackets. We're just multiplying what's in here by in here, right? And then we'll have plus alpha beta times beta gamma will equal to alpha beta squared gamma, because there's two b's here, so b will be squared, beta will be squared. So now we have this, and here's a tricky part. Now what can we do? We want to factor out something. so that we can get all of this equation again. What is it that you think we can factor out? Oh, let me just erase that. Yeah. What do you think we can factor out of all of this so that we can have no squares? We don't want any squares. So what we can factor out of this, we have an alpha here. We know we have an excess alpha, so we can take alpha out. We know we have an excess gamma, so we can take gamma out, and we know we have excess beta, because these are all squared. So we can plug these out of the equation, and so we'll have alpha, beta, gamma in one bracket. And now, what times alpha, beta, gamma will give you alpha squared beta gamma? So we want to multiply something, we want to multiply alpha, beta, gamma. These three are all being multiplied, right? We want to multiply these by something to get our first statement here, which is alpha squared beta gamma. It would be alpha, because alpha, beta, gamma times alpha is equal to alpha squared, if you're understanding what I'm saying. Plus, what alpha, beta, gamma times what will give us alpha, beta, gamma squared, plus gamma, plus, I hope you're picking up on it by now, alpha, beta, gamma times what will give us our third term, which is alpha squared, alpha times beta squared times gamma. It's of course gamma. It's of course beta, sorry. Oh my, I'm so sorry. It's of course beta. And this is what we'll have. So now we're able to break this down in a form where we have, it's very easily manageable, because the whole aim of this is to break it into the form of things that we actually do know. For example, we do know this is the formula for minus d over a, because the product, this is essentially the product of the roots, right? So we have minus d over a times what is the sum of the roots. Come on, dig deep into your brain. If you don't remember, you're probably shouting on the screen right now. The sum of the roots is minus b over a, right? So how do we get these d values? I know it might not make any sense at all right now, right? We have this equation up here. Now, this equation with x cubed plus 0x. Right? We have this equation, and how are we supposed to create a whole new equation from it? Well, it has the roots alpha, beta, gamma, right? The question gives us this. It says, given that the roots of this equation are alpha, beta, alpha, gamma, and beta, gamma. No, sorry. Given that the alpha, beta, gamma are the roots of this equation, we want to find the equation whose roots are alpha, beta, alpha, gamma, and beta, gamma. So because we're using alpha, beta, gamma, we can actually just break this equation down into a form by using the same things and the format that I gave you earlier, where we have x cubed minus sum of the roots. If we use both of these, we'll be able to get a new equation whose roots are what we just described. So from earlier, we would have known, oh, I'm having a little bit of a difficulty, that the sum of the roots is equal to 0. I'll just write this back over here so that it's very easy to see. Sum equals 0, c over a equals 3. By now you should remember c over a is the sum of the product of two roots at a time, minus d over a equals minus 2. So if we have minus d over a times minus b over a, what do you think the answer would be? We know our minus d over a value right here, and we know our minus b over a value because the sum is equal to minus b over a. So we substitute over c minus d over a for minus 2, and then we'll multiply that by minus b over a, and that will give us a sum, but the sum is equal to 0. And we know that anything multiplied by 0 is equal to 0. So far, we know that cubic polynomials follow the format x cubed minus sum of the roots, which we found was 0, sum of the roots which we found was 3, minus 3x squared, plus the sum of the product of two of the roots at a time, which is what we just worked out. Remember, we just worked out sum of the product of two of the roots at a time, right here. I'm trying to like highlight it so you can actually see it, right? So that would be plus 0x plus, oh, not plus, minus, and now we have minus question mark, because now we need to find the d value. How do we do this? So if you remember earlier, cubic polynomials follow this format: x cubed minus sum of the roots, plus sum of the products of two of the roots at a time times x. minus the product of the roots. So if we have, oh, so, um, oh my gosh, I'm sorry. If we have beta gamma, and we have to multiply this, right? Because now we want the product of the roots. So we'll have beta gamma times alpha beta times alpha gamma. Because remember, these are the roots of the new equation that we're trying to find. And so to find this new equation, we know that it must follow the exact format, the format that we listed earlier, where it's x cubed minus sum of the roots plus sum of the product of two of the roots at a time minus product of the roots. And for product of the roots, what we can do now, you cannot substitute the old value of product of the roots for this, because the product of the roots that we worked out earlier is for the old equation, right? We can only do that when we have them in a form conducive to that. So what I like to do for this, right, if we have beta gamma, alpha beta times alpha gamma, what I did in the test actually is I looked at it like this. It's the same thing as saying alpha beta, oh sorry, same thing as saying alpha beta gamma times alpha beta gamma, right? And this is a dot product, so this is not alpha beta gamma point alpha beta gamma. I hope you understand that by now. And so if it is that we have this, right, this is a lot easier to do. We know that the product of the roots, because alpha beta gamma, alpha times beta times gamma is the product of the roots, we know that that would be equal to minus 2. So we'll have minus 2 times minus 2. And this negative times negative is equal to a positive, and 2 times 2 is equal to 4. So now we have the equation, right? Alpha cubed, sorry, I'm so used to saying alpha now. X cubed minus sum of the roots. Do you remember what the sum of the roots is? I hope you've been writing this in your book. If so, you'll be able to actually just see it in your book. Sum of the x cubed minus sum of the roots, which is 3x squared, plus, now what was the sum of the product of two of the roots at the time? It was 0. So 0x. And then we have to subtract that. We have to have minus 4 now, right? Because minus the product of the roots, and we found that the product of the roots is equal to 4. Here's something that you really need to keep into consideration. You must always equate this to 0. If you don't equate it to a 0, it's not going to be an equation. It's going to be an expression, and you'll possibly lose marks for that. So I'd really advise that you understand that very important fact. Now I'm going to do one more example. Should I? Yeah, I'll do one more example, but this one might be a bit confusing, but I'll do it because we need it for the actual test. But just so you know, they'll give you two formulas. There are two formulas that I know for a fact they will give you. Well, they should give you. I don't know. I'm not an exam writer. But they should give you two formulas, and I'll get into those soon. So let's say we have given that alpha, beta, gamma, alpha, beta, and gamma are the roots of the equation. So they're the roots of this equation. 2x cubed minus x squared plus 1 equals 0. We want to determine, using this information, we're going to want to determine, whose roots are something else. But first, before we do that, what is the first step that I said previously? All we want to do is we want to find the sum of the roots. So we want to find alpha plus beta plus gamma is equal to minus b over a. And minus b in this case, we look for the polynomial with the second highest degree. In this case, the highest degree is 3. So the second highest degree is 2. So we'll have minus, and so since this is the second highest degree, this will have the b value, right? And the b value is minus 1. So we'll have minus times minus 1 over 2, because the a value is 2. And that's equal. Negative times negative is positive, so we'll get positive a half. Next, we want to find the sum of the product of two of the roots at a time. So we'll have alpha beta plus alpha gamma plus beta gamma. And that's equal to what? That's right, is equal to c over a. In this case, the c value. Now, where is the third x? We only see 2 so far, and we know from before that polynomials, cubic polynomials, follow the form ax cubed plus bx squared plus cx plus d. So if it is that we see nothing with just a single x, not x being squared or cubed, we know that that value is automatically 0. So we'll have the c value being 0 over 2, which is equal to 0. And next what we'll want to do is we'll want to have alpha, beta, gamma. Because remember, we always want to find these three things before we start the question. This is the product of the roots now of the first equation that we're given. And so that will equate to minus d over a. And from here, we can see that minus d would be minus 1 because we have positive 1 here. So minus 1 over the a value is 2, right? So now we'll have minus a half. And this will be the product of the roots of this first equation. Now, using this information, right, we want to determine whose roots are 1 over alpha squared, 1 over beta squared, and 1 over gamma squared. Now, as you remember from the last question, the first thing we want to know is the sum of the roots, because cubic polynomials follow the format x cubed minus the sum of the roots plus the sum of the product of two of the roots at a time minus the product of the roots. So if we want the sum of the roots of this equation, how could we get that? So we'd have 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared. And we can just add it like a simple fraction. Now, if it is that all the denominators are different and there's no way to make them like denominators, just try to close that part off, right? We just use all the denominators. So we'll have alpha squared, beta squared, gamma squared. Now, how many times does alpha squared here go into alpha squared, beta squared, gamma squared? It goes in there beta squared, gamma squared. If you don't understand this format, or not format, but way of adding fractions, I'd recommend that you go and learn it, because this is a very useful thing to know, especially in pure math. I actually think it's mandatory. It's not like a good thing to know. You have to know it. So how many times is beta squared going to alpha squared, beta squared, gamma squared? So we'll cross out the beta squared because we know that beta squared into beta squared is 1. Well, not 1, but it cancels out. And it will leave us with alpha squared, gamma squared. And then we'll add that. And so gamma squared into alpha squared, beta squared, gamma squared. We'll cancel out the gamma squared and we'll have alpha squared, beta squared. Right? Now, here's the thing. They'll give you a formula for situations like this. But before we get to that, let's actually get it into that formula. So we know by the laws of indices that a squared times b squared inside brackets is the same thing as saying ab squared. So let's use examples. Let's say we have 2 squared times 4 squared. This will be equal to 2 times 2 is 4, and 4 times 4 is 16. So 4 times 16 is equal to 64. Right? It's the same thing as saying 2 times 4 squared, because this will equal to 8. 2 times 4 is 8 squared, and 8 squared is equal to 64. So another foundation thing to know. But yeah, so in this equation here, we have beta squared times gamma squared. So we can say that beta times gamma all squared plus alpha times gamma all squared plus alpha times beta all squared. And we also have to keep on remembering to put it over. Oh my, what's a lead line? Oh, forgive me. Today's not my best line drawing skills. Line drawing day, sorry. So we'll have this over alpha squared, beta squared, gamma squared. So the test will actually give you a formula. I believe I've seen it on all the past paper questions that have ever dealt with this. It will say that when it is that you have this situation where you have beta, the situation on top as our numerator right here, the equation for this actually, well, not equation, but the formula that we can use to solve this, right, is equal to alpha beta plus alpha gamma plus beta gamma all squared minus 2 times the product of the roots, which is alpha beta gamma, times the sum of the roots, which is alpha plus beta plus gamma. Quite a beefy formula. I recommend that you know it because, I mean, it won't hurt to know, you know. And this will all be over alpha squared, beta squared, gamma squared. Please don't forget to put this because I actually lost marks because I completely forgot to put the denominator, which is obviously my fault. I was just out of it for that exam. So now that we've broken it down into a formula we can actually use, we know that the sum of the roots, the sum of the product of two of the roots at a time, which is what we just found out, is equal to 0. Right? We worked this out because we got it into a form. We worked the other equation, which we don't know anything about, into a form where we can use the values from this equation that we do know to help find the other value. So it's going to be 0 squared minus 2. And now we want to have the product of the roots. What is the product of the roots here? The product is equal to minus a half. 2 times minus a half. And I will multiply this by the sum of the roots. And as we see, the sum of the roots here, because it's minus b over a, sum of the roots is a half. So times a half. All over. And now here's the thing. Alpha squared, beta squared, gamma squared is the same thing as saying alpha, beta, gamma, all squared. So instead, we'll get into a form because we don't know what alpha is, right? We don't know what that is, and we don't know what beta is, and we don't know what gamma is. So we can't square all of them and multiply them by each other. So we'll use the law of indices, or well, exponents, and we'll work it out into a way that we do know because we do know what alpha, beta, gamma is equal to. We found the values of alpha, beta, gamma prior to this, like when multiplied, alpha times beta times gamma. We found those values. So now it'll be over alpha, beta, gamma all squared, right? Hopefully this is very easy to click so far. So the numerator now is equal to 0, because 0 times 0 is 0. And minus 2 times minus 1, right? Minus 2 times minus 1 is equal to 2 over 2, which is equal to 1. And that will be multiplied by a half. Wait, hold on, I'm sorry. I made a little mistake. So we'll have 0 minus 2 times minus 1 over 2. I hope this way is a little bit easier. So minus 2 times, so it's equal to positive plus 2 over 2, which is equal to 1. So we'll have 0 plus 1 times a half. And 1 times a half is the same thing as saying a half. Sorry, I just wanted to work it out a little bit like more broken down because just in case you didn't understand it, I want you to understand exactly where you don't understand. Because that's kind of the key to learning. It's just knowing what you don't know. But it's also the hardest part of learning if you don't know anything. So, yeah. So we have positive a half. And what was this that we were even working on? This is equal to the sum of 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared. So we have our first thing, the first part of our equation, right? We have the sum because it's x cubed minus the sum of the roots plus the sum of the product of two of the roots at a time minus the product of the roots. So now we'll go to the sum of the product of two of the roots at a time. So if we have 1 over alpha squared, 1 over beta squared, and 1 over gamma squared, the sum of the product of two of the roots at a time is equal to this 1 over alpha squared times 1 over beta squared, and then 1 over beta squared times 1 over gamma squared. And then that will be added to 1 over alpha squared times 1 over gamma squared. It's a lot of 1/overs, and it sounds very confusing right now. If you still don't know anything, I'm very sorry. Just try to follow along. Pause the video and just try to work the questions out. As long as you have the first formulas down, like you have them swatted, not swatted, but you remember them, they're in your long-term memory, you've encoded them properly, you should be able to solve any cubic polynomial question, because they're all just about application. So if 1 over alpha squared, and sorry, let me not do it this way. Let me break it down a little bit more again. 1 over alpha squared times 1 over beta squared, and that will be added plus 1 over beta squared times 1 over gamma squared plus 1 over alpha squared times 1 over gamma squared. So this is the same thing as saying 1 over alpha squared beta squared plus 1 over beta squared gamma squared plus 1 over alpha squared gamma squared, right? Now if we're adding these right, what will happen is that we will need add common denominator. So instead of having alpha squared beta squared alpha squared, and beta squared gamma squared, like it doesn't make any sense to put all of that back, right? Because we're just trying to find what would be able to be the lowest. So instead, right, our LCM would now be alpha squared beta squared gamma squared. Now, why, you might ask? Because there's no point in putting all of these, repeating all of these terms like alpha squared beta squared gamma squared, because if you have 1 over 2 and 1 over x times 1 over y, 1 over xy times 1 over y, and you don't want to just multiply both sides by x, it would make no sense to put x, y, y, because it will automatically go into the x, y, y. Yeah. So instead, we would just have 1 over x, y. No, not 1 over xy, but like would have the LCM just being xy, right? Because xy can go into this, and y can also go into this. So this would be 1 plus x, right? So now that we know that, hopefully that clears something up, because I actually had a problem learning that part a little bit. So alpha squared beta squared into alpha squared beta squared times gamma squared goes gamma squared, plus, I'm going to move a little bit faster now because I hope you're following, right? And we know, right, we know how we can solve this now. Because if we have alpha squared plus gamma squared plus beta squared, it's the same thing as saying, right, there's a formula for this. It's going to be alpha plus beta plus gamma all squared minus 2 times alpha beta beta gamma alpha gamma. Right, this is the formula we'll use for when we have addition signs in between. Addition signs right here, the addition signs are right here, and they're all squared. So this is equal. So we know the sum of the roots, right? Sum of the roots, and this is sum of the roots of the original equation. Please don't mix them up, right? The sum of the roots is equal to a half squared minus 2 times, and we know that the sum of the product of two of the roots at a time was 0. So it's equal to a half squared minus 0, and that is equal to a half times a half, which is equal to 1 over 2 times 2, which is equal to 1 over 4. So now we know the sum of the product of two of the roots at a time. So now our equation is like almost done. We're like just about finished, right? Because we have x cubed minus the sum of the roots plus the sum of the product of two of the roots at a time, right? Wait, hold on. I almost did it again. I almost did it again. I'm so sorry. I almost did it again. We completely forgot to do the alpha squared, beta squared, gamma squared, right? So it's equal to a quarter divided by alpha squared, beta squared, gamma squared, equal to a quarter over alpha, beta, gamma squared, equal to a quarter over alpha, beta, gamma, which is the product of the roots, is equal to minus a half squared, which is equal to a quarter over a quarter, right? And that's equal to 1. I'm sorry. I'm so sorry. I completely forgot. I almost did this in the exam, actually. I almost did this in the exam. Oh, also, the sum of the roots, sum of the roots, sum of the roots, sum of the roots. I also did it for this one. It would be a half over a negative a half squared, which is equal to a half over that's positive and this will be equal to 2. So the sum of the roots is equal to 2. The sum of the product of two of the roots at a time is equal to 1. I'm so sorry. I completely forgot. I hope you're screaming at me right now. Right? Because I completely forgot to divide it. I actually did this on my exam, by the way. Like, I got a pure math test recently and I did this on the exam and I lost a mark. But I'm actually not looking at the exam paper itself because I kind of like to work it out raw. I like to, if I get something wrong, I'll fix it. But I'm sorry if it's kind of distracting because I'm also trying to cement this knowledge in my head as well. So now we want to find the product of the roots. So the product of 1 over alpha squared, 1 over beta squared, and 1 over gamma squared is equal to 1 over alpha squared, beta squared, gamma squared. And we know from earlier that this is equal to 1 over alpha, beta, gamma all squared. And we know that alpha, beta, gamma, 1 over negative a half squared. And this is equal to 1 over a quarter. And one way I like to do this is I just put this over 1. Wait. No, sorry. I just like to just do it this way. 4 times 1 is equal to 4. But in the exam, as long as it's permitted, just use your calculator. It's really not that deep. Even if you know it, unless you're strapped for time, like extremely dead for time, I'd just say just use your calculator because human error can always happen. So we have x cubed, right? And what is the formula that all cubic polynomials will follow? Please tell me the formula. I hope you remember. Right? It is x cubed minus sum of the roots, which I just fixed and said was 2x squared, plus the sum of the product of two of the roots at a time, which we just found out, and we said it was 1, right here, plus 1, minus the product of the roots, which we just found out was 4. So, the equation that has the roots 1 over alpha squared, 1 over beta squared, and 1 over gamma squared is equal to x cubed, x cubed, yeah, minus 2x squared plus x minus 4 is equal to 0. Because remember, if you do have the 0, this will no longer be an equation and it will be an expression. So that's all today. Cubic polynomials is a really short topic. If you pick up on the concepts, it's very easy. I recommend that you read your textbook, whichever textbook your teacher has recommended, and practice. Use the questions in the textbook, also past paper questions. There are lots of past papers online. If you don't have them, you can comment down below and I can make a Google Drive and just send them all to you. But that's assuming anyone ever watches this video. So yes, I hope this video was useful. If it was not, please watch someone else's video. Don't give up. As long as you keep on working, your hard work will come into the benefits of your hard work will actually come. Trust, I've seen it firsthand. So good luck everyone on your exams. I hope you do well. And I hope I do as well as well. I hope I do well as well. Yes, goodbye. My next video will be on logs, surds, and indices. And then after that, I'll do functions and then the modulus function. And then if anything, I'll just go over truth tables. But I don't think anyone really needs truth tables. I'll just do it just because to have the full module 1 finished. Okay, goodbye.